In this video, I'm going to give a brief introduction related to real analysis. So first, let us see what is meant by analysis. Analysis is the detailed examination. It is the in-depth study of any element or structure of something. So in analysis, analyzing something in the sense we are looking deep into that particular matter. So here, real analysis is that branch of mathematics which deals with the study of behavior of real numbers, their properties, sequences, series, real functions, and many other concepts associated with a real number. Here we refrain our study only to the real numbers. That's why the name real analysis. If it is complex analysis, there the study is refrained to complex numbers. So that's what the meaning of real analysis is. So before really going into the in-depth study of real numbers, let us see just how the evolution of numbers happened. That's kind of story of evolution of numbers. So number system has grown over years. It's not spontaneous process. As civilization evolved, people started to make use of numbers in a useful way. Hence, numbers became an integral part of human life. So we already know that we can't live without numbers now. Numbers are kind of integral part of, they are embedded in the entire system. So we are nothing without numbers. So we are so much attached with the numbers. So that's what the significance of using numbers in our life. So it all started with counting numbers, which were used in all daily aspects of life. And these counting numbers are called as natural numbers. They are denoted by capital letter N. The set is denoted by capital letter N, and it all has the elements 1, 2, 3, 4, and so on. These are all called as counting numbers. Now, after once you get the counting numbers, they are used for counting purpose. Suppose if you have 5 pens, and if you don't have any pens now, somebody has stolen your 5 pens. So in that case, you have nothing. So how exactly to represent that nothing? The existence of nothingness is denoted as a zero. So that's how the concept of zero has came into existence, which give rise to the set of all whole numbers. Then that zero is attached to this natural numbers, and it has become a new set called as set of all whole numbers, which starts from 0, 1, 2, 3, 4, and so on. These are all representation for our convenience, so that whenever you are referring counting numbers, you can just refer the set n. Whenever you are referring whole numbers, you can just refer the set w. That makes your work easier. So all these are collected together. That's why they are called as sets, and they are named by some particular letter, and we will be referring that particular letter whenever we want to refer to that particular set. Now suppose I have an account in the bank, and I have 200 rupees in that account, and I would like to withdraw 300, which is not possible. Suppose the banker is agreeing to give me 300, but there will be a due of 100 rupees. So in case if you want to print how much is there in your account, then definitely it will show you minus 100. Means there will be a scarcity. There is a due of 100 rupees. So usually the scarcity is always represented using negative numbers, which give rise to a new set of numbers called as integers. They are denoted as Z. Z stands for Zahlen. Zahlen is a German word for number. So that's why the letter Z stands for all negative numbers, 0 as well as the positive integers. So not just the scarcity, you can represent you can use these negative numbers to represent something which is below the standard level. Like if you have 0 degrees Celsius as standard temperature, then below which whatever comes, that will be considered as a negative temperature. That's minus 2 degrees Celsius, minus 10 degrees Celsius, and so on. Now to represent next part is we are having natural counting numbers, we are having whole numbers, and we are having integers. Now that is also not enough. We want to do we want to get some more numbers. That is because to represent a part of a whole, suppose you have a complete circle here, and I have divided this circle into 4 equal parts. Now this is one part of that circle. It is represented as 1 by 4. These two parts will be represented as 2 by 4. That is what meaning is. Part of a whole is represented by using rational numbers. So the set of all rational numbers is denoted as q, which are having the numbers of the form p by q. P comma q are integers, and q not equal to 0. So they are called as rational numbers. Once the rational numbers were introduced, then it was assumed that rational numbers are complete, so there are enough natural numbers, rational numbers. But that was not so. Rational numbers are always not complete. Means there is a gap. They are not continuously stretched on the number line. That's how irrationals were introduced. That means, suppose if you take a square of side 1 unit, then if you find the diagonal of that square using the Pythagoras theorem, the diagonal value should be root 2. But root 2 is not rational number. Rational number means it is either terminating or it is recurring. See, for example, 1 by 3 if you take, 1 by 3 is a rational number. So because 0.333 and so on, it is, though it is not terminating, it is recurring. Suppose if you take 1 by 2, it will be equal to 0.5. This is terminating. Though it is not recurring, it is terminating. So either it should be terminating or it should be recurring. But root 2 is neither terminating nor recurring. So in those kind of numbers will not come under rationals. They can't be represented as p by q numbers. They can't be represented in p by q form. Hence, there was a necessity to introduce new numbers. They are nothing but irrational numbers. So hence we got rationals, we got irrational numbers. Now let us come to the reals. What these real numbers are. Rational numbers and irrational numbers together form the set of all real numbers. Real numbers are nothing but these rationals and irrationals together called as set of all real numbers, and it is denoted by capital letter R. It is called as scripted R, and we can write the set of all real numbers in an interval form as minus infinity to infinity. So the set of all real numbers. Now when you come to the real numbers, and when you draw a real line, probably this kind of real line, this real line is always complete. So the meaning of that is our real line is full of real numbers. So if you start from here 0, then towards right you have positive numbers, towards left you have negative numbers. So 1, 2, 3, minus 1, minus 2, minus 3, and so on. Here you have all those real numbers, 0.1, 0.2, 0.3. So that means it is full of real numbers. There is no gap. That's what the real line is. The meaning of real line is complete. So this completeness is defined formally. So but when we are speaking mathematically, we can't say that there are full real numbers on the real line. We should be telling in a better way, that is in the language of mathematics. So formally it is proved using the least upper bound property, or equivalently, there is another way of proving. If you prove that real line is a complete metric space using the concept of Cauchy sequence, then we can say that that real number line is complete. But in our usual language, the real line complete in the sense there are infinite real numbers. You can walk along these this real line. So, but in case if you consider a set of all natural numbers, 1, 2, 3, 4, 5, and so on. So in this case, you can't walk along the natural number line. You have to jump from 1 to 2, 2 to 3, 3 to 4, because there are no natural numbers between 1 and 2, 2 and 3. But that won't happen in the case of reals. There are infinite real. It is full of reals. There is no gap anywhere. You can walk along the real line. That's what the meaning of completeness property of real numbers. So that formally it can be proved using the least upper bound property, or equivalently using the complete metric space concept. So the in conclusion, what I can say is mathematics is not just one way of doing things. It's all about different possible ways, which are all equivalent. That's what this last sentence mean. Either you can prove it as upper bound property using upper bound property, or else you can prove the completeness of R using R as a complete metric space. All both mean the same. They are contributing towards the completeness of real line. So maths is not just one way of doing things. There are several ways, but all mean the same. So that is what the conclusion I can draw after studying the number system, especially the real number system. Now once if you know the concept of real numbers, then what you do in real analysis is important. So real analysis involves the following. What are reals? That's kind of formal definition. Now I said that it is a combination of rationals and irrational. Set of all rationals and irrationals together form the set of all reals. But formally, what the real numbers are, because we have to give the mathematical definition. Now if you have the real set of all real numbers, can it be considered as a field? Can the set of all real numbers considered as a ring? Order relation can you define on R? What is the completeness property or axiom on R? Archimedean property, if it exists in R, so how exactly you will state that? Density of Q in R, what exactly the meaning of density of Q in R, and extended real line or real number system, and some topology on R, especially the point set topology. So these are all concepts which come under real analysis. These are all basic concepts. Then later you will be having sequences, series, convergence, metric spaces, that are all extended concepts. But these important concept, they act as a very basic concepts when you get into the analysis of the real number system. So firstly, in this video, what we learned is all about what real numbers are, how the number system evolved, and what is the completeness property of real numbers, and how the real number line looks. So those are our concepts covered here. In the next upcoming videos, I'll be sharing with you all these formal concepts of real analysis. So please keep watching my channel. Please share, subscribe to my channel. Thank you so much.